Okay, another thing that's going to happen is they're going to give you situations where they get you to draw the angle or draw the triangle. So I just start by drawing a random triangle. If they give me an angle, I like to put my angle where that red dot is. But they didn't give us an angle this time. So that's usually my start because it really looks like the activity that we did, so we can see the ambiguous case if it comes up. This one, they just give us 3 sides. So I'm just going to label randomly KMN, it doesn't matter. But then K to M is 16, K to N is 11, and M to N is 6. And you can criticize me for my scale, that's perfectly fine. Right, in this one, doesn't look like K to N is the longest side in my drawing, but it's 11 and the other side 16. And this side, that's 6. Looks really same length as the 16 side. It's okay. You don't have to draw to scale. It's just there for us for reference. Now, we want to find measure of angle M. And so we're going to use this formula from your formula sheet. And again, the letters don't matter. The important thing is that whatever angle you want to find, you have to use its opposite side in that particular spot in the formula. If you use it somewhere else, it will go wrong. So, here we go. I'm going to write cos. No, I'm not. Try that again. I'm going to write cos. I want to find angle M. So the first thing I'm going to write on my formula is minus 11 squared over here, just to make sure, because the M and the 11 are opposites of each other. That's the only reason the letters are important in your cosine law formulas. Next, it doesn't matter which one you choose as A and which one you choose as B. And again, I want you to take out your calculator and type this in right now on your own to see if you can do this. I like to use the fraction button if you have it. If you don't have the fraction button, try it with however you have. 16 squared plus 6 squared minus 11 squared over 2. And you can put brackets or you can multiply. 2 times 6 times 16. And push enter. And I get 57 over 64. If you have it set up to go as a decimal, 0.890625. Awesome. Okay. Now, according to your CAS rule, and you'll see a lot of videos online don't do this, but then I find people forget their CAS rule and the importance of reference angles. According to your CAS rule, you see that cos is positive. Do you see that the possibilities are here in quadrant 1 and here in quadrant 4? Does it make sense that angles in quadrant 1 are between 0 and 90 degrees? And angles in quadrant 4 are between 270 and 360 degrees. Okay? Obviously in a triangle, 4 is never a possibility. So you can see why online videos sometimes skip this. They skip the reference angle and they just go and solve. But I'm going to say, remember always that you're finding a reference angle first. So my reference angle for M would be cos inverse of the 0.890625. And it just so happens that if your only one is in quadrant 1, then your reference angle will be the same as M, which is why sometimes that idea is skipped on some online videos, but I'm going to do cos inverse of that answer. I get 27 degrees. Does it ask to the nearest degree? Right? Technically, 333 degrees is the other answer. That would work, but we put a line through that because it's not possible. The only possibility is 27 degrees. Okay. Are you okay? Has everyone done this one? I'm going to erase this and just do this, the second one over top. I want to make sure everybody's done writing this one down. Good? Okay. So erase this triangle. Again. So again, they give us three sides, so it doesn't matter which you pick as S, T, and U. And STU is 20, TTU is 6, and STC is 16. Ooh, this one I'm actually pretty closer to scale. Maybe. Maybe not. Okay. And I want to find angle T. So whenever you're finding an angle, this is when you're going to use this form. And what's really important is the angle T goes with the side 20. So when I start to write this out, the very first thing I'm writing out is making sure that I see that this 20 and this T go together. The other sides don't matter. And it's really nice that it's really kind of nice that they use the same numbers because I can cheat a little bit on my calculator. So why would they do almost the exact same question? Well, something interesting is going to happen in the next step. So I'm going to type this into my calculator. There we go. I'm going to go and highlight this from before because now instead of minus 11, everything else is the same, except now it's minus 20. So that's nice that I could just retype that. And I get negative 9/16, which as a fraction, negative 0.5625. 0.5625. Negative 0.625. So it's interesting because it's negative, because now according to your cast rule, it's here or here. And I already know because it's a triangle, it cannot be over 180 degrees. So I'm going to put an X through that one. I'll find it and I'll X it out again later. But there's only going to be the answer between 90 and 180. So here it's really important that we find our reference angle and that we remember when we find reference angle, we always do the inverse of the positive, not the negative. So I'm going to go to my calculator. I'm going to go cos inverse. I'm going to go 9 divided by 16 instead of writing the decimals because it saves me one button. So efficient, I know. And I get 55.771 degrees. That's my reference angle. So my actual angle T, well, in quadrant 2, it would be 180 degrees minus my reference angle. Technically, quadrant 3 would be 180 plus my reference angle. So 124, does it say it around to the nearest degree again? Yes, it does. 124 degrees and 236 degrees. And of course, the 236 doesn't make sense with the triangle. Does the 124 work? Yeah, it's possible, right? interesting observation. So if you got the negative, you're going to get an obtuse angle. Interesting observation for you. This will seem like common sense after I tell it to you, but until you're told it, you probably never knew this. The biggest side is always opposite the biggest angle. Logically, that makes sense. The longer you make the side, what happens to the angle is you make it longer and longer and longer, the angle gets bigger and bigger and bigger. The smallest side would be opposite the smallest angle. So we would know that that 6 had to be the smallest one. Also, if you watch this online, sometimes you'll see people online do cos inverse and they'll use the negative. And what's weird about using the negative here is it actually gives you the right answer. But then you will, if you start doing that and not using the reference angle in the questions where you need the reference angle, you're going to get those ones wrong. So it's important that when we do cos inverse, we find a reference angle first. It's not until AP Calculus that you really come to understand why this happens with cos inverse, that it gives you the answer in quadrant 2. When you do sine inverse, it gives you negative answers in quadrant 4. It's like, what the heck? Why is that happening? That'll come in AP Calculus. But right now, use your reference angles. Circle questions 5 and 7.